All right, so this one's going to review the partial fraction decomposition. I actually said you guys did a pretty good job on your quiz on this problem. I think there's a couple common mistakes. When I get to it, I'll go over it. But overall, you did pretty good, but I want it to be fresh in your mind before we add to this process, which is what we're going to do today. So the first thing we want to do with partial fraction decomposition is what? Good. Factor the denominator. So this would be x minus 4 and x plus 2. And then for each term that's there, we're going to split into separate fractions, right? So this becomes a over x minus 4 plus b over x plus 2. And the order there is not important. You could switch those two. And then we want to focus on what's missing from each of those fractions and multiply it times whatever's in the numerator. So this would get the x plus 2, and this would get the x minus 4. And I would have done the same thing to the denominator, but we're skipping that step, which allows us to do one less thing, but realize that why we can do the next step is because we would have multiplied by the top of the bottom. Once we do that, the denominators are the same, so we can set the numerators equal to each other. So I would say that 3x minus 1 equals a times x plus 2 plus b times x minus 4. Everybody with me so far? Yep. Now what's my next step? Good. So I'm going to plug in a value for x that cancels out each one individually. So if I want to cancel out the a, I could say that x equals negative 2. And then everywhere there's an x, I plug in negative 2. So 3 times negative 2 minus 1 equals a, negative 2 plus 2 plus b, negative 2 minus 4, negative 6 minus 1, which is negative 7, equals a. If I've done this correctly, this will be 0, which cancels out my a, plus b times negative 6, and then divide both sides by negative 6, and I get 7/6. There's my b. With me so far? Yeah? Okay, then I want to cancel out the b. So what would I plug in there? Positive 4. And everywhere there's an x, I'm going to plug in a 4. So this is 12 minus 1. This cancels. 11 equals a times 6. And a equals 11 over 6. And there's my a. And then my last step is take those and plug them back in the place of the a and the b that we had at the top. So 11 over 6, actually not my last step, my second last step, would go over x minus 4 plus 7 over 6 over x plus 2. And then remember, we can't leave the fraction within the fraction. So I bring the denominator down, 11 over 6 times x minus 4 plus 7 over 6 times x plus 2.
Do we leave the denominator unfactored?
Yes, so don't put the factor in. I didn't take points off if you did it on the quiz because we only had one day of practice on this. But we actually want to do the opposite, and we want to take it out. Okay. So from here on out, I want you to practice taking out that 1/6. If there's the same denominator in both of them, then factor it out. So I can pull out the 1/6, and I would get 11 over x minus 4 plus 7 over x plus 2. So again, for test purposes, if you've got a least common denominator like that, I expect to see it pulled out. Carlos?
Is there always going to be like similar number at the bottom?
No, not always. But if there is, you want to take it out. So there's one last part from 7.3, which is called partial fractions with repeated linear factors. So when a factor in the denominator occurs more than once, the exact same factor, then each factor has to be accounted for. If I were to take this left side, let's just say, like pretend we didn't have the discussion already, pretend this was the other day, and I said to take that and break it down into its factors. When you break x squared and x squared apart, it becomes x times 2x minus 1. Right? We agree on that? Yeah. So if I was to find the least common denominator here, or if I were to break that apart, what would you expect to be the factors? X squared, right? A over x squared plus b over 2x minus 1. Really, you would probably break it apart like that, yeah? Right? That's what you would assume to do, okay? Now, if I had actually worked out the right side as it is, I would not get the left side. And it's like a special case. The special case is if there's a repeated factor. So if there is a single term raised to a power, or even a expression raised to a power, like if I had x plus 5 raised to the second power, this is called a repeated linear factor. That exact factor repeats itself at least one more time. And in that case, you actually have to work your way up to the exponent. So if I had an x squared, I would have to write it as a over x and b over x squared, and then whatever's left. If I had an x to the third, I would have it as a over x plus b over x squared plus c over x to the third. So for each factor that's there, you actually have to work it up from the first power. Otherwise, if I were to simplify the right-hand side and go left, it actually wouldn't work. So let's start those out. So this just says write the form of the partial fraction decomposition of the rational expression. Don't solve for the constants. So pay attention to the difference between A and B. A has an x squared, yes. But what can I do with that? I can take out an x. So when I do, I get x and then x minus 4. Is there a repeated factor there? No. So even though it's squared in the beginning, if I factor it out, there's not a repeated factor. This is your normal a over x plus b over x minus 4. When you look at b, can you factor this out? No. And there's actually 3 terms there. X, and then x squared plus 3, and x squared plus 3 repeats again. So this gets an a over x, a b over x squared plus 3, and a c over x squared plus 3 to the second. Yep.
Could we like set it up where we like multiply everything, like just like I don't know how to say it. Like x
Expand it?
Yeah, expand it.
You don't want to. So we're working the other way,
Okay.
right? Yes, it's still an equivalent fraction, but the goal is to decompose it, break it down, not work it forward.
Okay.
Carlos.
Doesn't that make it like what you just did, make it 3x squared plus 3 because you put like an x plus 3 and then x plus 3 squared?
You mean if we solve it?
Yeah.
So when you actually work through, you would see, like, we're not going to work through this example, I'll work through the next one. But when you would work through, you would actually see that when you're missing things in the numerator, they work out to give you just enough to get you to the left-hand side. Without that second x squared plus 3 raised to the first power, you don't get where it works out on the left side. Your answer would not work. So you have to account for that linear factor.
So the last factor is x squared plus 3
Squared, yep. So you want to do it to the first power, to the second power. If it was raised to the third, I would do it to the first, to the second, and to the third. If it was x to the 8th, I would do a over x, b over x squared, c over x to the third, d over x to the fourth, all the way up until I got to the highest exponent. All right, so we're going to work all the way through this time. Write the form of the partial fraction decomposition of the rational expression. So we're going to start the same way. Is the bottom factorable? No. Is there a repeated factor? Yes, x squared is repeated, right? So this would equal a over x plus b over x squared plus c over x plus 1. Now I fill in what's missing from each one, right? So I'm going to take and multiply. This a over x is missing what?
X times x plus 1.
Good. X and x plus 1. Oop. B is missing what?
X plus 1.
Just the x plus 1. And C is missing?
X squared.
X squared. And then again, I would have multiplied both that and the top and the bottom. The bottoms would have all been equal, and now I can focus on just my numerator. So 4x squared plus 2x minus 1 equals a x times x plus 1 plus b times x plus 1 plus c times x squared. Now you're super smart, you know the next step, but it's going to be wrong. So wait and see what happens. So I'm not going to work through the process, but talk it out, okay? Normally I would plug in a value to cancel out the a, cancel out the b, and cancel out the c. You with me? Yeah? So what could I plug in to cancel out a? A 0 or a -1. So let's say I picked the 0. A 0 would have crossed through a and c, leaving me with b. And I would get a value for b. I'm not going to work it out because you're going to see what happens in a second. But just follow me. Then let's say I went to solve for b. What could I plug in? -1. -1 is going to cancel out a, cancel out b, and leave me with c. I'm still good. Then I would want to cancel out c. What would I plug in to cancel out c? 0. We've already done 0. If I plug in 0, it's going to cancel out c, it's going to cancel out a, and it's going to leave me b again. There is no way to solve a the way that we've been doing this. So herein lies the catch to repeated factors. You have to do it an entirely different way, okay? You can the way that we are going to actually do this, we're going to set up a system. And the way that you do it, you can actually do all partial fractions. So let's say fast forward 20 minutes and we've really enjoyed that process, which you're not. But let's just say you do. You could actually go back and do all the things that we've done up to this point with partial fractions in the way that we're going to do it, okay? The difference is, 1, it's a little bit more complicated. 2, you cannot do what we have done before with repeated factors. So as soon as you see it's a repeated factor, you have to know that you have to approach it a different way. Yep.
For a, do we distribute in the...
Yep, so that's what we're going to do. So I'm going to go back to the start of here where we wrote out all of our numerators, okay? And I'm going to expand the right side. So I want to take that ax and multiply it times both the x and the 1. So this would be ax squared plus ax. I'm going to take the b and distribute it, plus bx plus b plus cx squared. So instead of breaking it apart, we're actually keeping it all combined and distributing it out. So if this is an equation in which it's balanced, then whatever's on the right-hand side should equal whatever's on the left-hand side. So the next thing I'm going to do is group together all of my x squareds and all of my x's and all of my constants. So I have ax squared and cx squared. I'm going to group those together. And then I'm going to group together all of my x to the first, ax and bx. And then all that's left is my constant, which is b. If there was more than that, I would group that together as well. Yep. When this part up here, 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 here. So I look at what's over here, right? Which technically would have been x times x times x plus 1. And I just say what's missing from the bottom. So on the first one, I'm missing the second x and the x plus 1. On the second one, I'm missing the x plus 1. And on the last one, I'm missing the x and the x, which is x squared. Okay, so on the right-hand side, I already grouped it together. On the left-hand side, I'm going to match it up. So the 4x squared is going to match with my x squared. The 2x is going to match with my x. And the minus 1 is going to match with my constant. So I'm grouping them together, and then I'm going to break it into those 3 parts. So 4x squared should equal ax squared plus cx squared. 2x should equal ax plus bx, and -1 should equal b. So I broke them apart by the term. All of the squareds get grouped together, all of the x to the first gets grouped together, and all of the constants get grouped together.
Are there always going to be like a counterpart?
Yes. So there are special cases, but I actually assigned it in the first class, and I was like, this is way too hard. When there's not, it means that you have to take the numerator and divide it by the denominator and to the point in which they do, so that the degrees have to be the same in both the numerator and the denominator. But I took them out. Let's focus on, yeah. I think this is complicated enough as it is. All right. So I handpicked some questions. But is it possible? Yes. There's an added step, but we're not going to do that. All right. So now what do I notice about all of the terms in the blue, all of the x squared terms? What do they all have? An x squared. So I can actually divide both sides by x squared, and it will eliminate my third variable, leaving me with 4 equals a plus c. So my goal here is to get rid of those x's. Go to the x to the first. What do they all have? An x. Cancel them all out. 2 equals a plus b. And then the last one, there is no x already. So what we've just done is create a system, okay? I have 3 equations. 4 equals a plus c, 2 equals a plus b, and -1 equals b. The really complex of these will have 3 variables and 3 equations, but you know how to solve those now. That's why this is in the spot it is in the chapter. Luckily, this one is already a little bit easier, right? We know what b is. What could I do with b? Good. Plug it in here. 2 equals a minus 1. A equals 3. And now I have b and a, and I can plug a into the top. And c equals 1. And my whole goal with these questions is to find the numerators that would match with that fraction in the beginning. So I'm going to take them and plug them back in. So a is 3, b is -1, and c is 1. And then remember, we don't want a negative in the top, so we're doing 3 over x minus 1 over x squared plus 1 over x plus 1.
And you can do the system for the other problems that we did last
Yeah.
yesterday?
Yeah, you could do the same system for the way that we did it, the other problems. Questions so far? All right, so I separated it out again. As soon as I realize that there's a squared, this is like a red flag should go off that says, okay, this is a repeated factor. I can't do it the way I've been doing it. So I would get a over x plus b over x squared plus c over x plus 2. And then the a is missing the x and the x plus 2. The b is missing the x plus 2. And the c is missing the x squared. So then I wrote all the numerators out. I would then expand and distribute anything that needs to get distributed. So this is ax squared plus 2ax plus bx plus 2b plus cx squared. And then I want to group together the x squareds and set it equal to the 9x squared. So 9x squared equals ax squared plus cx squared. I want to group together the x's. So 3x would equal 2ax plus bx. And then I want to group together the constants. So -1 equals 2b. Everybody with me so far? Yep. Okay, so the one I can actually cancel from the x squareds, I can cancel out the, from all the x squareds, I can cancel out those x squared. So 9 equals a plus c. These all have an x, so 3 equals 2a plus b, and then the constant would stay the way that it is. So my system is 9 equals a plus c, 3 equals 2a plus b, and negative 1 equals 2 times b. Again, I'm to a place where I can solve for a variable, so b would equal negative 1/2. And then I'm going to take that, plug it into the one with the b. So I get 3 equals 2a minus 1/2. I can add the 1/2. I could multiply it all by 2. However you need to do it so that you make sure you're careful with your fractions is totally up to you. If I multiply everything by 2, this is 6 equals 4a minus 1. 4a would equal 7, and a would equal 7 over 4. And then take that, plug it in there. So 9 equals 7/4 plus c. Again, you can multiply everything by the denominator or just subtract 7/4. So this is 36/4 minus 7/4 or 29/4. And now I've got c. So I've got a, I've got b, I've got c. I'm going to take them and plug them back in. A is 7/4 over x plus b, which is negative 1/2 over x squared, plus c, which is 29 over 4 over x plus 2. And then I want to bring all those denominators to the bottom. So 7 over 4x plus, or minus, sorry, minus 1 over 2x squared plus 29 over 4x plus 2. So because they don't all have the same denominator, you can leave it the way that it is. I could pull out a half, but then they'd all still have the 4 in the bottom, so it doesn't really simplify it much. So if I thought this would be the same thing, this was like a multiple choice, 29 over, or standardized test, you might see it like that. That's the same thing. But because it doesn't take them all out, okay, I'm okay with you leaving this one in. Questions on repeated factors, any of the process?